New power supply incorporates a large color touchscreen with bold graphics, power meter, tip temperature display, password interface, and power curve display. The displayed information can be accessed via a communication port for analysis. The Metcal soldering revolution continues with connection validation. To meet the industry requirements and mitigate the risk associated with hand soldering, it is necessary to modify the operator's approach to the soldering process. Metcal's new approach to hand soldering closes the loop on hand soldering by introducing exciting new technology into the electronics manufacturing industry. The Metcal cartridge is made of a heater of proprietary design consisting of a non-heating copper core and an outer heating layer of magnetic alloy. The composition of the alloy predetermines the tip temperature. As a high-frequency current is passed over the heater, the magnetic alloy causes the current flow to become confined to the skin. This is the skin effect. The resulting high current density causes rapid heating. As it heats up, the magnetic alloy passes through its Curie point temperature, and it loses its magnetic properties. This eliminates the skin effect, causing the migration of current to the low-resistance non-heating copper core of the heater. As the tip cools slightly, the alloy passes back through the Curie point temperature and its magnetic properties are restored. The skin effect immediately returns and heating begins again, repeating the cycle. Thus, the tip self-regulates very close to the Curie point, maintaining constant temperature. As the tip temperature is constant and the heat is not stored in the tip like a conventional soldering iron, the Smart Heat system applies direct power to the joint. Soldering results in the creation of an alloy between the solder and the metal surface that does not melt. The IMC forms due to a chemical reaction between the solder and the surface metal. Although usually disadvantageous due to the intermetallic phases being typically brittle and prone to crack growth, small amounts of IMC formation indicate that the soldering process has formed a good solder joint. There is no indication to the operator that the process successfully meets any requirement other than visual. Starting with Smart Heat, connection validation changes the approach to soldering by creating a closed-loop feedback system to complement the visual standard. Validation of a solder joint requires the ability to identify the correct solder geometry, detect the transition of solder from solid to liquid, and calculate the intermetallic compound formation without adversely affecting throughput or repeatability. Metcal's patented technology incorporates a complex algorithm and hardware solution to calculate the IMC as a function of power over time. Connection validation provides feedback to the operator via the light ring embedded in the handpiece. Successful intermetallic compound formation triggers a green light signaling to the operator that the ideal solder joint is created. To facilitate the connection validation calculation, each intelligent cartridge stores key information which include values related to tip mass, thermal resistance, thermal efficiency, cartridge serial number, date lot codes, among others. This makes each cartridge truly unique. While visual inspection provides visual feedback to the user, the ideal way to demonstrate connection validation is through cross-sectional analysis. These cross-sections demonstrate the IMC results. Solder training to the industry standard is the norm for companies around the world. This training provides the basics, but experience is gained on the production line and in the research lab. Producing quality products in large part relies on the experience of the user and the production process. Connection validation complements the basic training and normalizes the output based not on the varying degrees of experience of the user, but through the formation of the IMC. Selecting the correct tip geometry and heater series for the application is a basic component of the soldering process and is essential for efficient soldering. Pick a solder tip geometry that maximizes contact with the connection. A flat, blunt tip will transfer more heat than a fine, pointed tip. Choosing the largest tip possible will improve performance and enhance tip life. Metcal's heating technology incorporates multiple alloys to achieve temperatures within the 500, 600, 700, 800, and 900 ranges. The specific metallurgical properties define the maximum temperature achievable by the heater. This enables a user to select the correct temperature range for the job by balancing performance versus risk factors like maximum board or component temperature, flux activation temperature, tip life, etc. With basic solder training, proper tip geometry selection, and the right heater series, the user is now ready to solder using the connection validation system. The solder events start with a red-green flash to the operator. The flash signals to the user that the solder event has started. The user applies solder per their process, forming a thermal bridge. When the green light illuminates, the solder joint is complete. A red light on the handpiece signals to the user that the solder conditions have changed or that the IMC has not formed correctly. An example is prematurely removing the solder tip away from the joint. Metcal is also transforming the way users access critical solder event information. The new power supply incorporates a large color touchscreen with bold graphics, power meter, tip temperature display, password interface, and power curve display. During cartridge construction, each intelligent cartridge is programmed with key information unique to each cartridge. Sensing the power requirements of the load and armed with the key cartridge information, the connection validation power supply calculates and displays the solder tip temperature. In fact, our solder tip temperature display achieves an accuracy of plus or minus 2% at idle for solder tip temperature. In addition to the real-time solder tip temperature display, the connection validation power supply does not require calibration as the temperature is calculated rather than relying on an embedded sensor. Knowing the solder temperature at the tip provides vital information to the process control engineer to better understand the soldering process at the point of use rather than guessing at the target temperature, as is commonplace in other equipment in the industry. The displayed information can also be accessed via a communication port when connected to the CV5000 monitor software on your PC. 4 key features, power, temperature, solder time, and IMC formation, are captured for each solder event and displayed and can be replayed. Failed solder joints remain a constant source of printed circuit board failure. Today, reliability relies on visual inspection, operator experience, and skill, control of influencers like tip geometry, tip temperature, and collection and analysis of process data. Each factor involved with the formation of the solder joint is an element of risk and can affect either throughput or repeatability. Mitigating this risk in hand soldering requires the identification of these factors, and with connection validation, you can. The risk associated with soldering activity takes the associated control of variables defined for the process and places success or failure entirely into the hands of the operator. The soldering activity relies on the skill and experience of the operator to judge whether each solder joint conforms to the visual standard. The visual standard and operator skill do not account for the correct formation of the intermetallic compound. Connection validation helps mitigate the risks associated with poor solder joint quality to the organization through normalization of training, improved process control, and reduced scrap related to poor solder joints. Metcal's soldering revolution continues with connection validation. Smart Heat, made smarter. Exclusively by Metcal.